Good day, good day, good day, good day. Welcome back here to our another session on our YouTube channel. So like always, my name is Tifla, and if you're new here, welcome, and if you've been here for a while, welcome back. So we are trying to deal with Euclidean geometry. As you can see, this is the first session of our Euclidean geometry. So we made 3 Euclidean geometry papers. We compiled 3 Euclidean geometry question papers. So the first one and the second one will be dealing with mostly the grade 11 and the previous year's stuff. And then the third one will be so much focused on the proportionality theorems and the similarity, right? So without wasting time, let's just get straight to it. These are just simple questions. Let's just go to our first session. So in the diagram, ABCD is a cyclic quad. So what I always advise students is that always make sure that you're having at least 4 colored pens or pencils or crayons that you can at least draw what you are told, and then you can at least give all the angles that you know on that session, so that it doesn't become so much hard for you. So we're having this cyclic quad. So again, once you're told that this is a cyclic quad, ask yourself, what do you know about a cyclic quad? We know that the opposite angles are supplementary. So it means that this A1 plus A2 is equal to C2 plus C3. So if possible, you can write it somewhere else. So this is A1 plus A2 is equal to C2 plus C3. And you know that the reason is opposite angles of cyclic quad, right? So they're supplementary. And also you know that angle D plus angle B should also give you 180. Sorry, here I didn't write it nicely. So this is this plus that is equals to 180. The same reason, right? Yes. And also you know that our C1, so C1 being the exterior angle, so this should be equivalent to A1 plus A2, and this is the exterior angle of cyclic quad. So whatever that they give in this information, it means that it is very, very much important. So you just place it aside on a rough paper or on a scribbler there, then you can be checking everything from that. So already you can see that this angle that is outside must be equivalent to this whole angle. So we can solve the questions, or maybe here they told us that our A1 is half of B. So it means that our B should be twice A. So whatever that is here, if this is X, this our angle B should be 2X in that order. So now you know how to deal with this. Whatever the situation, whatever the question that they will ask you, you now know how to deal with this. And our angle C1 is equal to 86 like shown there. Right. So let's see the questions. What are the questions? So the first question says, calculate with the reasons the value of A1. So let's go back here. So here you can see that already our A1, it is in this equation, right? So A1, it is the only one that is unknown, while is A2, it is known, and C1 is known, right? So we can just quickly say on our 9.1, we can say that our angle C1 is equal to our A1 plus our A2. And what will be the reason? Exterior angle of cyclic quad is equal to the opposite interior angle. So now you are done with the reason. Now you know what is C1. C1, it is 86. So our 86 will be equivalent to A1 plus our A2, which is 46 degrees. So now it will be simple to deal with A1. So our A1 will simply be 86 degrees minus 46 degrees, which is equivalent to 40 degrees. As simple as that. So now you'll be done with your first question. And it was just 2 marks. And your 9.2. Hence prove that AD is equivalent to DC. So we want to prove that your AD is equal to DC. So how do you prove that the lines are equal? So if the lines are in the same triangle, the quickest way you can prove that these are equal, it is to prove that this angle A1, it is equivalent to C2. So once these angles are equivalent, we know that these lines are equivalent. The reason being, angles opposite equal sides are equal, or sides opposite equal angles are equal. So now, what is the value of this? We notice that this is 40 degrees. So we are also trying to prove that this is 40 degrees. So how can we do that now? How can we go around that? So I think there's information that we didn't use, because now we have proved that this is 40 degrees, but they told us that this is half of that. So it means that our angle B will be equivalent to 2 multiplied by 40. And the reason they told us that A1 is half of our angle B, which therefore makes our B equivalent to 80 degrees. So now we know that this is 80 degrees. So we know that this and this, there's a relationship between these ones. Like I always say that in most cases, the shape, we can see that this is a circle quad, but however, when you want to master Euclidean geometry, focus mostly on the triangles. So let's try to move this angle so that it can come to this side, so that we can have this angle, and it will be easy to find that angle. So what do we know about this now? These angles, like we already shown there, we said D plus B must be equivalent to 180. So we can do that. So angle D plus B is equivalent to 180 degrees, and the reason being opposite angles of cyclic quad, like that. So now what can we do now? So it means that now our angle D becomes our angle B, becomes 180 minus our angle B, which makes our D equivalent to, so our B, it is 80, so minus 80, right? So 180 minus 80 gives us 100 degrees. So now we know the value of our D. But there's something else that we know in this triangle ADC. So in triangle ADC, what do we know? We know that our A plus our D plus our C2 is equivalent to 180 degrees. So this is sum of angles in a triangle. So our A there, it is 40, plus our D, which is 100, plus our C2 must be equivalent to 180. So our C2 must be 180 minus 40 minus 100, which this gives us 40 degrees. So this means that our C2 is equivalent. So our C2 is 40, which is equivalent to our A1, which is equivalent to 40 degrees. So we can now conclude. What can we conclude now? We can now conclude that, therefore, AD is equivalent to DC. Why? Because sides opposite equal, angles are equal. So we can say that these sides, these two sides, AD and DC, they're opposite equal angles. So once they're opposite equal angles, it means that they're also equal. So those were just 6 marks for free. Let's move on. Let's see the other questions. So in this one, they said in the diagram, O is the center of the circle. We can see that. Use the diagram to prove the theorem which states that the angle subtended by the chord at the center of the circle is equivalent to twice the angle subtended by the same chord at the circumference. So we are trying to prove that TOP, this angle, it should be 2 times this angle. That is what we are trying to prove. So before proving any theorem, what you have to do first is to construct. And according to this, we construct a line from K there, passing through O, and then going to another point. You can call it maybe point Q there. And this will give us O1 and O2. And also here we'll be having, let's say, K1 and K2, like that. So now, how do you prove now? How do you prove? We are going to prove first in this triangle. You can see that we created 2 triangles here. We're having KOP and we're having KTO. So in triangle KTO, however the situation that you want it to be, in triangle KTO, what do you see in triangle KTO? We can see that our angle K1 is equivalent to angle T. Why are they equal? Because you can see that OK and OT are equivalent. This line is equal to this line. Can you guess why? Yes, because these are radii. So we can say KO is equals to TO equal radii. So which will make this angle equivalent to this angle, right? But what else can you see? So if K1 is equals to angle T, which means that this, our angle O1, can you see this one? That is exterior of this triangle. So this exterior angle, we know that it is equivalent to this plus that, right? Exterior angle of a triangle. So our O1 is equivalent to our K1 plus our T. And what is the reason? Exterior angle of triangle is equal to sum of opposite interior angles. So this is equivalent to the sum of the opposite interior angles. So now, if this is equal to this plus this, and we've already said that this is equivalent to that, so it means that this will be equal to twice K1. So which means that our O1 is equivalent to K1 plus K1, because already T is equivalent to K. So this O1 can be equivalent to K1 plus K1. So angle O1 will be equivalent to 2 times K1. And this we can say it, maybe our equation 1, or however the situation that you want it to be. And now we can move in another triangle, triangle KTO. PO. So in triangle KPO, now we can also see that our angle K2 is equal to our angle P, because also these lines, they're equal, they're radius. So a radius is any line from the center to the circumference. So we can say our K2 is equivalent to our angle P. Why? Because our KO is equivalent to our PO. These are also equal radii, right? So from then also we can say that our angle O2, it is this angle that we created outside there. So O2 also is equivalent to this plus this, because this is the exterior angle of this triangle, right? So our O2 can be equivalent to, our O2 can be equal to K2 plus our angle P. Why? Because this is the exterior angle of triangle being equal to the sum of opposite interior angles, right? So but our K2 was already equal to our P, so we can substitute this P with K2. So our O2 can become K2 plus K2, which this gives us 2 multiplied by K2, right? So this can be our equation number 2. But you know that if this side is equivalent to that side, and also this side is equivalent to that side, it means that if we add this side and this side, we can also add this side and this side. So what am I trying to say? This is what I'm trying to say. We can replace that by just saying our O1 plus our O2. You can see that here we're having O1 and O2. If you can see that, you're having O1 and O2. So O1 and our O2 can be equivalent to our 2K1 plus 2K2, right? Because this was equivalent to that, and also this is equivalent to that. So these two are equal. So what is our O1 plus our O2? O1 plus O2, we can see that this is TOP. So O1 plus O2, this gives us TOP. So angle TOP will be equivalent to 2. We can factor out K1 plus K2. But what is our K1 plus K2? You can see that K1 plus K2 gives us TKP. Can you see that? TKP is given by that. So now we can just replace K1 plus K2 with that, right? So it means that our TOP will be equivalent to 2 multiplied by what? By TKP, which therefore means that our TOP is equivalent to 2 multiplied by TKP, which this is what they wanted us to prove. And then you'll be done like that. That is how you can prove this theorem. You first construct, and then you make sure that you are mixing that, just like the way that we did. So we can move to the next question. I'm sure a lot of this you are already familiar with this, right? This is just revision. I don't know what's happening. This is just revision. So here we are given that in the diagram, O is the center of the circle and ABCD is a cyclic quad. OB and OD are drawn. So once you know that you are having the center, just know that this angle at the center must be equivalent to 2 times this. So if this is x, this should be 2x. And again from this we can see that this angle here, that is angle A, if we add it to this angle that is C, we get 180, because opposite angles of a cyclic quad are supplementary. That's what you have to know always. So we are given that our O1, it is given by 4x plus 100. So our O1 is equal to 4x plus 100. And also our C is equivalent to x plus 34. Right. So what is the question? Calculate, giving reasons, the size of x. So now if you are asked to find the size of x, what you have to do is that you have to make the equation that is relating the two angles that you can be having, right? We can see that this O1 and C, there's no relationship between these two. We cannot make an equation out of these two. However, we know that this and this, there is a relationship, because we know that this is twice that. And in return, this angle plus this angle, they give us 180. So that's the equation that we want. So it means that first thing we have to turn our O1 and try to find our angle A. So we know that our O1 is equal to 2 multiplied by our angle A. What is the reason? Angle at center is equal to 2 times angle at the circumference. Right, it's equal to 2 times the angle at the circumference. So which means that our O1 already, we know that this is 4x plus 100 is equal to 2 multiplied by angle A. So we can divide throughout by 2. So our angle A can become, if we divide by 2, this becomes 2x plus 50 degrees. So this is the value of this angle, 2x plus 50. Now we know the value of this angle, we can make an equation, because this plus that, they give us 180. So we can say our angle A plus our angle C should be equal to 180 degrees. And the reason is opposite angles of cyclic quad are supplementary. Right. So A1, this is 2x plus 50 plus our C1 is x plus 34, should give us 180. So 2x plus x, this is just 3x. And then we can take our 50 plus our 34, which this gives us 84. This should be 180 degrees. So taking 84 that side, our 3x will be equivalent to 180 minus 84. I'm sure that will be 96 degrees. Now we can divide by 3. So which means that our x becomes, if we divide by 3, that will be 32 degrees. Please forgive me, I don't have a calculator, but you can verify that, because like the most important thing is for you to see the procedure. The answer, you can use your calculator, but I'm sure like it's 32, right? Just like that. So once you when you are trying to find the value of the variable that is unknown, first make the equation that can satisfy that you have numbers that you can try to solve for x, because you can see that this relationship between this one and this one only, we don't have enough to solve for x, because this is just half, I mean this is just twice that, so we can divide this by 2 to get that. So we don't have a number that we're equating to. However, this one plus this one, we know that they give us 180. So once we have this one with the value of x and this one with the value of x, and then we equate it to 180, we can solve for the value of x. Just like that. I'm sure like for now we would have chowed how many marks? So that would be 6 plus 5 plus 5. That's 16 marks already for free. So let's see this one now. Again, these are 6 marks for free. In the diagram, O is the center of the larger circle, OB is the diameter of the smaller circle, so this line is the diameter of the smaller circle, right? So what do you know if you're having a diameter? Once you have the diameter, know that a diameter subtends how many degrees? 90 degrees. Before you can go any further, just do that. Chord AB is of a larger circle intersects the smaller circle at M and B. So write down the size of OMB and provide the reason. And already we have already said that OMB is equivalent to 90 degrees. Why? Because this is angle subtended by a diameter, or you can say angle in the semicircle. You just do the way that you want. So these are 2 marks for free. So this is the mark on saying 90 and also the reason. So 8.3.2 now. If AB is equals to root of 300 units, so AB is root of 300 units and OM is equals to 5 units. Calculate, giving reasons, the length of OB. So now we can see that in this larger circle, we can see that this chord, it is perpendicular to the line drawn from the center. So what do we know? A line drawn from the center perpendicular to the chord bisects the chord. So this means that this side must be equivalent to that. So we can first state that AM is equals to MB. Why? Because line drawn from center perpendicular to chord. Or some people, they like to call it center chord theorem. So it just depends, but I think the most appropriate reason that you can give is line drawn from center perpendicular to the chord. So if this line is equivalent to this line, so it means that this AM will be root of 300 divided by 2, and also this will be root of 300 divided by 2. And bear with me, I don't have a calculator, I'm just working this. So some of the things we're just gonna finish that with the calculator. Here we're just here to show each other the ways, the procedures, right? So we want to find the length of this. So once we're having this situation, we can see that triangle OMB is a right-angled triangle. Can you see that? So theorem of Pythagoras can apply there. So OB squared must be equivalent to our OM squared plus our MB squared. And the reason being theorem of Pythagoras, because this is a right-angled triangle. So OB squared can be equivalent to our OM, which is 5 squared, plus our MB, which is root of 300 over 2 squared. So OB squared gives us 25 plus, and this will give us what? I'm sure this will give us 300, and 2 squared gives us 4. So this will be 200 divided by 4. So OB squared gives us 25 plus, and if we divide this by 4, we get what? 75. So our OB squared gives us 100. So doing a square root there, which makes our OB equivalent to 10 units. So if I didn't make a mistake, this should be 10 units, as simple as that. So already again, we're having 6 marks for free. I think this is our last question in this question paper that we made here, right? So I think this one is a little bit too much. I'll do the first two questions and I'll leave you to do 10.3. However, I'll come with a correction after a while, right? So this one is the one that you mostly need all your colored pens, so that you can draw whatever that you can draw and you can show whatever that you can show, so that you don't have a problem. So let's see. Let's just, yeah. In the diagram, PQRS is a cyclic quad. So we know that this shape is a cyclic quad, the one that is inside. So what you can do already, just state all the angles that are equal. So already you can see that this angle must be equivalent to this one, Q2, because these are angles in the same segment. And also we can see that our R3 must be equivalent to our S4, angles in the same segment. And also our S5 must be equivalent to our what? P3, angles in the same segment. And lastly, also you can see that our P2 must be equivalent to our Q1. So these are also angles in the same segment. So always go with something that you can write with, right? And also we can see that this angle that is here, Q1 plus Q2, must be equivalent to S3. Can you see that? This is the exterior angle of a cyclic quad, must be equivalent to the opposite interior. So also we know that this 2 plus this 2 is equals to 180. This 2 plus this 2 is equals to 180 as well, right? So these marked lines, they will help you to figure out all the questions, all the angles that are equal without a problem. And we're also given that PQ is equals to PR. So which one is our PQ? So this PQ is equals to our, PQ is equals to our PR. So PQ is equals to our PR. So what can we get from that? We can also get that this angle is equivalent to that. But already we have said that this angle R3 was equivalent to that. So it makes that these four angles, they are now equal. They are connected because the other angles are equal. You know that once you have two lines that are equal in the same triangle, it means that the opposite angles are equal. The tangents to the circle through P and R meets QS produced at A. So you can see that we're having two tangents here. We're having this tangent, and also you know that tangents from the same point are equal. So it means that this line and this line are equal to this point here, right? So which makes these angles to be equal as well. So it means that this whole angle must be equivalent to this whole angle. Once you use different colored pens, you can see that this should be very easy, right? Now let's go to the questions that we're having. Let's see how we can answer that. They said prove giving reasons that S3 is equivalent to S4. And you can see that S3 is equivalent to that. Can you see with these lines that we made? So now let's make the connection. What is the connection between these? We can see that our S4 here is equivalent to our R3. So let's write that down. Our angle S4 is equal to our R3. And the reason being angles in same segment. And also we can see that this our angle S3 is equal to Q1 plus Q2. So S3 is equal to Q1 plus Q2. 2. And the reason being exterior angle of cyclic quad is equals to opposite interior angle. But lastly, we are told that this line is equivalent to this line. Can you see that? So which makes that our R3 is equals to Q1 plus Q2. And the reason being angles opposite equal sides are equal. Which sides are we talking about? We're talking about PR equivalent to PQ. So now we can conclude. You can see that, sorry, this is R3. So you can see that this is equivalent to that, this is equivalent to that, but these two are also equal. So if these two are also equal, so it means that these two are also equal. So we can conclude that our S3 is equal to our S4, and the reason being both equal to R3 and Q1 plus Q2, and we'll be done like that. Simple, right? Yeah, sometimes it gets so much simple. You just need to study this so much harder so that you see how you are supposed to do that. So now we are given, we are told to prove that SMRC is a cyclic quad. So this shape, we are asked to prove that this is a cyclic quad. So how do you prove that a shape is a cyclic quad? You prove something by showing its properties. So if we're asked to prove that this is a cyclic quad, one thing that you can use that R1 plus R2 is equals to S5 plus S6. Then it will be a cyclic quad. Or we can prove that this angle plus this angle, C2 plus this is equals to 180. It will make it a cyclic quad. Or we can prove the exterior angle. So what is the exterior angle of this triangle? This S4, it is exterior to R1 plus R2. So if we can prove that S4, if we can prove that it is equal to R1 plus R2, then we can prove that it is a cyclic quad. Or if we can prove M4 is equal to C2, then it proves that this is a cyclic quad. However, we don't have any relationship between this and this yet. But you can see that there's a relationship between this and this because they're both equal to one angle. Right? So let's see. Don't forget that we're told that this is a what? This is a tangent. So which makes our R1 plus our R2 equivalent to Q1 plus Q2. We know that an angle formed by a tangent here, it will be equivalent to the angle formed in the alternative side there. Can you see that? Q1 plus Q2. And what will be the reason there? It is tan chord theorem. So these are equivalent with tan chord theorem. But from above, we're also from proving that our S4, where is our S4? Our S4 was also equivalent to our Q1 plus our Q2. Can you see that? Our S4. So we can say our S4 is equivalent to Q1 plus Q2. And here, if you are lazy to write a reason, you can write from above. Yes, it is a reason. From above. Or you can say that it is already proven. You don't have to prove things many times. Once you prove it once, you can use it as long as it is the same question. You can prove it, you can use it over and over again. So we can say that, therefore, our S4 is equals to our R1 plus R2. And the reason being both equal to Q1 plus Q2. So now, therefore, it makes our SMRC is a cyclic quad. Why is it a cyclic quad? Because the exterior angle is equivalent to the opposite interior angle. So once you can prove that the exterior angle is equivalent to the opposite interior, so this is our exterior, it is equivalent to our opposite interior, then this shape qualifies to be a cyclic quad. As simple as that. Right. Yes. So lastly, what do you have to do? In this question, they said prove that RP is a tangent to the circle. So this is the question that I'm leaving you with to try on, and I'll come with the solution. However, I'm giving you a hint. So they said prove that RP is a tangent. So which one is RP? Sorry about that. So RP is this line. So they said prove that this line is a tangent to what? To a circle passing through P, S, and A at P. So P, S, A. So if you're trying to prove that a line is a tangent to 3 points, all you have to do is prove that this angle that is formed here must be equivalent to what? To this angle that is formed at the alternate side. So I'm giving you the work to try to prove that our P2 is equivalent to A1. Once you solve this and you send the solution, or maybe you can take a pic of your solution and then you can send to our email address. You can also send your account number and then we'll send you something for the weekend, right? So if you don't know our email address yet, you can email us at Stifler extra lessons at gmail.com. You can email us that. So try to do that and send us the solution with the explanation, and we can send you something to use over the weekend. And again, the email address is stiflerextralessons@gmail.com. We'll be back again with the solution and also with Euclidean Geometry paper, the second paper, right? Enjoy the rest of the day. I'm sure you asked your maths paper 1. Have a lovely day. Goodbye. And if you haven't subscribed, please subscribe, like, and follow.